Voice. Good evening, everybody. My name is Frances Clark, and I am the program coordinator for Teton Plants, which is a chapter of the Wyoming Native Plant Society. We welcome you all here tonight. We have a wonderful speaker who's going to start very shortly. But I did want to welcome you all to Nature Nights at the Teton County Library via Zoom, I'm afraid, right now. Nature Nights is held every Tuesday evening at 6 p.m. It's a lecture series co-sponsored by the Teton County Library, which makes this Zoom space available, Teton Plants, the Jackson Hole Bird and Nature Club, and the Geologists of Jackson Hole. So every Tuesday night, you can find something cool out about nature, whether it's a rock or a plant or a bird or a mammal or an insect. So please keep Tuesday nights in mind as Nature Nights. And someday we really hope to be back at the Teton County Library where we can see each other in person. So let's get started. First of all, please, everybody, I think most of you know the routine, but if you can make sure you're muted, that makes sure we don't get any distracting background music, background noise from your cat or your phone or what have you. As I said, we are starting to record this program. Unless there's an urgent question that's sort of immediately sort of relevant as far as clarification goes, if you could save your questions to the end, that would be great. And any questions should come in through the chat, please. That would be great. And then we'll take your questions through chat, but we may call upon you to unmute and ask your question in person. The other thing that I think most of you know, but you should be able to adjust your view button so that you can see as much of the screen as you want. That sort of dialog box is up in my screen in the upper right. And then you'll also see a little sort of two striped lines that can help you. If you slide it to the right, it will make the PowerPoint picture bigger and the people smaller. And you can go back and forth depending on how you like to do that. So those are the technical matters. So without any further ado, let's get going. Paul has been studying the vegetation ecology and human impacts all over the world, but with a focus on Western United States. Paul Rogers has studied geography at the Utah State University, University of Wisconsin, and has his doctorate from the Utah State University in ecology. Currently, he is adjunct professor at the Utah State University. Paul worked for the U.S. Forest Service for 16 years, conducting monitoring activities and publishing results from the interior west of the United States. In other words, he's really anchored in the ground here. Dr. Rogers' ecosystem monitoring research has taken him around the United States, as well as to Canada, Europe, Africa, and Australia. At one point, we were emailing back and forth, and he was in Uzbekistan. I had to look it up on the map, I have to say. Wow. He was a visiting fellow at the University of Queensland in Australia in 2014, and he was later awarded a very prestigious Fulbright Specialist Scholarship to Mendel University, Czech Republic in 2017. Again, he's been around the world. Paul has been prolific in his teaching of students, presenting professional workshops, writing scientific papers, and giving media presentations over the years. Last but not least, Paul is director of the Western Aspen Alliance and helps to organize Aspen Days, both here and elsewhere. Currently, he is working on issues related to disturbance ecology and wildlife impacts and benefits to aspen ecosystems. We are really extremely fortunate to have Paul Rogers here with us tonight to talk about aspen biodiversity. Welcome, Paul.
Well, thank you, Frances, and thank you all the whole Teton Plants and Wyoming Native Plant Society and whoever else is on. It's wonderful to be here. My first seasonal Forest Service job was doing grizzly bear habitat mapping up in the Moran area, south of the Teton Wilderness. So I kind of cut my teeth on learning plants. My favorite thing to say about plants, when I'm being perfectly honest, is that I've forgotten more plant names than I actually know now. But since then, I've deviated off into the fun world of lichen, lichen ID and lichenology, in addition to doing a lot of macroecology, and some of it as macro as you can get, which you'll see in a minute here. Anyways, I'm excited to be here. As Francis said, let me just get this thing rolling, if it'll advance. There we go. I run an organization called the Western Aspen Alliance, which is really a virtual organization with members across the West, professional members, mostly researchers, people that work for all the various agencies, as well as a handful of international members as well. And basically our mission is to get science and information, current science and information on aspen ecology into people's hands, and they decide how to use it and where to use it and so on. I am an adjunct professor. I teach environmental science at Utah State University, but mostly I'm research and running this organization, the Western Aspen Alliance. So we're gonna center on biodiversity today. Most of my photos are from the greater Yellowstone area or Wyoming, although there's a few deviations, but I high graded, you might say, for this audience, thinking that most people on are from that area, though they don't have to be. And I want to present some new perspectives. I would be surprised if I didn't say something new or at least challenging, which I hope we'll hear about in the question and answer section later, because a lot of folks feel like, yeah, I get aspen. I know that. That's pretty simple stuff. But as in any science, it's evolving. So I'll move on pretty quickly here. This is a forest, in quotes, from the southwest part of Wyoming. And a lot of the forests, particularly aspen forests in Wyoming, look like this. It may not be the grand, colorful forest that you're thinking of, although I would challenge you to say that these are biodiversity oases in a sea of sagebrush, and in other contexts in a sea of conifers. And we'll see how that plays out here in a minute. So here's where I'm heading in terms of this road mapping, this talk. Just a little bit of background to make sure we're all on the same page. I'm guessing a lot of people have the basics of the aspen ecology, but some things are changing in that realm. And then really kind of center on the idea of aspen as a keystone species. I think everybody probably knows what that means, but a species that if you removed it, a lot of other species would also fall out of a system. And in this case, in aspen, a very large number of species are dependent on this healthy aspen systems. And then I'm gonna deviate toward disruptions, disturbances, both pluses and minuses. Some people say aspen is disturbance dependent. That's true for the most part. Of course, we can always overdo a good thing. And then we'll kind of take a visual tour and sort of just some aesthetics and our friend diversity and some of the diversity and life forms that are supported by aspen. And then I'll just have a one slide thing about what the Western Aspen Alliance does as a nonprofit based at a university. So this is some monitoring. Obviously, you know where that is, that we did about 10 years ago. We were remeasuring some plots that have been remeasured since the 1970s up in aspen plots up in the greater Jackson Grovant area. And so here's my phrase for aspen, my ecology starter kit. Aspen is a beautiful thin-skinned, fire-loving clone. And then there's a big pregnant pause here, except when it isn't. So I'll look at some of the rules and then the exceptions. And the exceptions are becoming, like a lot of species, are becoming more apparent to us. So it doesn't always, another way to say is it doesn't always behave the way we think or say it should. And you get a first glimpse sort of there at the plethora of species that are supported in aspen systems. Compare that to a conifer dominated forest, for example, in your area. So there's obviously an aesthetic appeal. Scenes like this are abundant. There's beautiful photography from all over the West, and certainly in the Northwest Wyoming area. It's just pretty to look at. A lot of people love that because it's a yellow accent among a sea of darker conifers. In many locations around the West, it's the only broadleaf tree at all. And that has a lot of importance for biodiversity. So burrowing down in there, what do I mean by thin skin? Well, I think you know that there's active chlorophyll under a very thin bark. And there's pluses and minuses to that. This on the left is Elk Rubbings, and this is from down around Hoback area this past summer. I have several slides from a visit I made there to the Ricketts Ranch and some other areas around there. But it's easily penetrated. On the right there, sapsucker wounds, easily penetrated, which is good because animals can get insects from under the bark. In the wintertime, they can get nutrition in that active chlorophyll. So bear in mind that there's a very low level of photosynthesis taking place in aspen 12 months of the year underneath the bark. And the whiteness or not of the bark is a measure of the albedo or reflectivity. The less white it is, the darker shades it are, the more sunlight is penetrating that. This isn't a lot of growth, but it is nutrition in the trees that's readily available when the snow gets deep. So with this thin skin, thin bark, so to speak, it gets diseases very easily. It dies and rots, it dies and rots. Aspen lives shorter than its cohort of conifer species. There's good and bad to that. But it does get a lot of internal rot, which is wonderful for habitat for various species. But the trees die, they live and die a lot, and they have mechanisms for covering that. They live shorter, say, let's just say roughly 80 to 120 years, where the conifers will live, hundreds of years often. And so they're sort of operating at a different pace. You have two wheels here living inside the same system, one going a little faster than the other over time. This tree can get sun scald when it's exposed. If there's, say, a clear cut or a wind throw, it can get sun scald, which is a vector for disease as well. So the sun can damage it if there's too much sun. And finally, that thin skin is a very poor protector against fire. You'll notice that the older aspen have a thicker bark, anywhere from 1 to 2 meters up the bottom of it, when they get to be quite large in diameter. And that's a little bit of fire protection, but you can potentially have a stand replacing fire that never gets more than 1/2 meter in height or 2 feet, because these trees can be killed with a very low level of fire. But they respond very well. Remember, they're living on and reproducing. That's their skill. They reproduce much faster, much more intensely than their cohorts species of conifers. So good and bad with that thin skin. And this fire-loving part. Let's see, this photo is from near Baggs. So way down in the southern part near the Colorado border of Wyoming a couple of years ago. And you see this immense prolific response after a fire. And of course we know it's vegetative response for the most part. This is one of those new lessons that's coming along really fast. And I'll come back to that in a second. So it's fire loving, except when it isn't. This is not a fire prone forest at all. It probably would rarely burn under certain situations. This is from the eastern part of the state, in the Cheyenne area, and the Cheyenne Range, I think it's called. And so when aspen grows in a more pure form, it's sort of fire resistant. It used to be called an asbestos forest. It's not only because aspen isn't very flammable, but all the rich growth of species underneath, regardless of the species diversity, hold a lot of moisture. So it's only fire prone perhaps a couple of weeks in the fall in certain years before the snow comes and when all of the vegetation has dried out. So mostly it's fire prone, but when it grows in a pure form, it's not so much. And so a few years ago, and occasionally there'll be some references in here if somebody really wants to dive deeper into this science of aspen ecology. We kind of developed this scheme with Doug Shinneman, Bill Baker, myself, and Dominic Kulikowski of fire ecology of aspen. We don't really look into that a lot because we don't think of it as a species that burns. But basically the pink and red shades are when aspen grows in tandem with conifers, also known as cirral. That successional pattern that you might call this traditional aspen ecology. But we have these kind of two different tan types down there in the lower left, where they grow in the pure form, also known as stable aspen. And it's not fire dependent at all. And the disturbances that attack aspen are not stand replacing. They tend to be more individual trees and small clumps. And they have all ages, and it's a very complex system with only one major tree species. So there's some variety there. This is the famed Pando aspen clone. Some of you may have heard of that. In the center, stretching to both edges there, in the middle ground, everything you see that is green is one individual living being, thought to be the largest living thing on Earth.
Mm-hmm.
And if you want to get technical and nerdy, by dry weight mass. So we're not exactly competing with fungi that are 70 to 80% water weight. At any rate, that's a technicality. This giant clone gives you some sense of, here's what a clone is. All of these things, this 106 acres or 43 hectares for those of a metric proclivity, is all one living being. And it's probably been around certainly hundreds of years and likely thousands of years, but we do not know how old it is, despite what you read on the internet. So aspen's all about clones and clonal reproduction, right? Well, not always. On the right there is an aspen seedling. Particularly if you look at the lower leaves, they don't look much like aspen. On the left is an aspen sucker growing off of a root. We are now finding these aspen seedlings in most fires that we visit if we know how to look for them. The first year or two, they don't look much like aspen. And we overlooked them and we said, in quotes, this is a rare event. Well, it's clearly not the case anymore. And there's some recent science on that, how common these aspen seedlings are. So this is a whole field where we know about 1% of the knowledge. What is the role that plays in both space and time, the occasional inputs of new clones? We don't know yet. I just want to make sure you're aware that it's not all about clonal, vegetative, or sucker regeneration and recruitment, but most of our science so far for the last 100 or more years has been focused on that, but now we've got a new focus. What does that mean? We don't know yet. And if anybody reads the Mountain Journal, I wrote more of a popular article with this photographer, Lance Odit, on somebody came up with a clever title. Wilkerson, the publisher of that, Charismatic Megaflora. So that's a clone. And then we want to drive home the point that all aspen are not alike. They, in quotes, behave differently. And so these stable and cirral is the main break there. And you can see sort of that pure type versus when it grows and exchanges dominance over, say, 100 or 200 years with conifers, and how they work quite a bit differently. And so these different subtypes need to be treated differently in terms of restoration, in terms of management, whether it's active or passive management, because they're not going to behave the same. And we've been trying to treat all aspen alike. And by the way, aspen is the most widespread tree species in North America. Its sister species, which you'll see later, Populus tremula, is the most widespread tree species in the world because it reaches all the way across Europe and all the way across Asia. And so these widespread species shouldn't be expected to behave the same over such vast areas, such a broad ecological amplitude. And so understanding those different behaviors and different environments is pretty crucial. So let's switch gears here and talk about this idea of a keystone species. What does aspen support when it's healthy? And the inverse, what do we lose when it's not? From your area, some of you may know Don DeLong down there around Alpine and Afton. But he put together this list qualitatively about 10 years ago of just the animal species. The plant species would be significantly larger. Most aspen stands, if they're healthy, can support between 50 and 150 plant species. A wide range, I realize, but that's quite a bit more than their conifer forest nearby. So there's a lot going on there. What does this look like graphically? If you take sort of time zero after, let's just say it's a fire, and this is only the cereal aspen, the one that grows in tandem with conifers, you have this kind of pattern where aspen has a clear lead. It doesn't have to grow from seed, although we know it can. It can be up to a ½ meter tall within a couple of months of the actual fire. Whereas, you know, the conifers, they got to put that seed down, wait a year, start germinating. It's growing at a different pace. So aspen has the early lead. My scale is off here a little bit. It should be 50 in the middle and then 100. And these are this is just general numbers to give you an idea. But aspen has an early lead, and somewhere around 40, 50, 60 years, the conifer and cereal system will start to become more dominant. What I want to know here, and this is what this looks like sort of visually. You have right after a fire on the left, you have a couple years after a fire, that's 20 years after a fire in the middle, probably about 60 years, 80 years, and then past 100 years on the right. My cat has a lot to say apparently over there. This is the overarching message of the whole program. As the trend of aspen goes, so go all of those obligate species that grow under them. So people say, yo, you're just infatuated with this tree. No, I'm infatuated with this system. And it's supported by a keystone species that's aspen. And it grows a little bit differently than a lot of other trees, particularly in this area, with that vegetative reproduction. And it likes disturbance and it responds well to it, as long as there's not major disruptions. And I'm guessing you already know the punchline, there are major disruptions here and there. And so tracking those, understanding them, and recovering from them is pretty important. So that red line is sort of what we're after in this talk. So I mentioned earlier, I got all excited about lichens about 15, 20 years ago, and ended up actually doing my PhD research on lichens and their fluctuation with aspen and conifers through time, but also with air quality. Lichens are an extremely sensitive species to air quality, and they're a lot cheaper than putting a bunch of high-tech machines all over the forest. And they work best when you supplement them with a few high-tech machines. So this is Melanellia. This one is Exasperatula, I believe, the sort of olive green, brown, and silver, depending on what the weather's doing. And some Xantha Mendoza, the orange ones, some very small squamulose, little dots there on the far left, yellow ones. So different lichen species are going to specialize in aspen. And we did a study on that. And basically, you don't have to look at this whole thing. You can zoom in on a couple places where there's a white dot. And those 4 bars that repeat twice across the bottom are different stages. So number 1 is young. Number 2 is more dominated, still more dominated by aspen, but a lot of conifers. Number 3 is more than 50% conifers. And number 4 is that sort of older growth stage. But basically what I'm trying to point out here is that there are some species, such as the one in this slide, Melanellia exasperatula, that prefers this stage. There are other species that prefer the older stages, mostly the fruticose or bushy lichens. By the way, they also prefer high quality air. You see there's some stage 1 and different stages, as you can see there. And that's just the statistical makeup there. So the species aspen and the forests around it evolved through time, and species come and go that specialize in those different successional stages. But let's talk about disruptions, not just human disruptions. Things didn't go really well between Megan and John. it appears. And they had a breakup. But what I'm really talking about, all fun aside, a friend sent me this photo from up here in northern Utah. You see the big diversity, the color and under the aspen forest, but our disturbances, different system disturbances, and not so much the social ones. This is the one that most people think of, forest fire. Disturbances happen, but you notice constantly in the media, they're treated in a negative light. It's all about value statements. And one of my least favorite words is unprecedented. This stuff has never happened before, which is patently untrue. However, fires happen and aspen generally benefit from them. And we need periodic fire in our forests for them to be healthy. This is sort of an unusual one from the high plateaus in Utah. Volcanic flows happen. A little bit more rare, but still aspen can grow in and around those. Just like if you ever get over to Craters of the Moon in south central Idaho, there's aspen stands in and amongst the lava flows there where there's few other things growing. What other kind of disturbances? This is down near south central Wyoming, again near the Colorado border, but further east. We have mountain pine beetle killing off a lot of the trees. Aspen loves this stuff. It's an opening. Sometimes the aspen itself doesn't even need to be disturbed just so we have more light and more water resources available. And then this one that we have a lot of in this part of the West is avalanche shoots. Aspen often is the only species that can grow in these because they can get pushed over, flattened, and bounce back up. Now, they're not going to be those really big aspen. If they get too big, they'll become too brittle and they'll get snapped off. But you'll see the partitioning of the forest here where there's commonly avalanche shoots. This happens to be from Logan Canyon near where I'm standing today. So we have different disruptions, these natural ones, that's fine. And aspen responds really well to them. We have human disruptions, and we have a long history of favoring certain species over another. This is from the Black Hills in 1966, where they physically plowed up all the aspen because they wanted to grow more ponderosa pine. We did one of our aspen days that was split on the far eastern border of Wyoming. We split it between Wyoming and South Dakota. And, what is it, 50 years later, 60 years later, they've completely reversed. They've seen the light, you might say. They've seen the gospel of aspen. And now they're like killing themselves because they took out so much aspen on purpose so they could grow more saw timber. But they lost a lot of diversity there. Some of the stuff gets pretty harsh. This is just north of Arco, Idaho. We have cyanide in the stream. It's killing the aspen from gold mining. This is in your area. I'm not at full disclosure to say where, because this was an illegal case. But the person on the right told the airplane to fly along, to spray along the fence and kill all the aspen so they'd have some, in quotes, healthy grazing land. Well, the pilot did exactly that. They flew right along the fence, half on one side and half on the other. On the left, they have a conservation easement. And they are managing for diversity. And that tree is very sick and chemically poisoned. And all the forest behind, about 8 acres of the aspen forest were all killed for this. So we have some odd and heavy human intrusions in our aspen systems if we're not watching out for them. So the elephant in the room these days is climate change. And there's mixed scenarios here. On the lower left there, we have, well, let's start with the right, the upper left, sorry. Average monthly temperatures. We're pretty good at modeling this in our climate change predictions. Precipitation, the lower left, is a little bit more difficult. So there's not as high a certainty in precipitation. However, clearly the system's warming. In many cases, that'll cause drying, that'll cause shorter winters, longer, drier seasons, and so on. We all know that. So there's kind of a couple scenarios here and some research to back it up. And the first, if you're familiar with climate modeling at all, this is called a climate envelope model. We take a habitat and we project it forward through time. It's what it looks like on the left currently, and basically the aspen habitat in red shrinks over time. And if you imagined every mountain to be a perfect pyramid, as you push the species uphill, the area would get smaller. And so that's basically what this is. All aspen in the West is treated the same, doesn't talk about disturbance, it doesn't talk about those different aspen types and how they might react. So it's a fairly simplistic, but it's the first shot over the bow. What we might lose aspen habitat with more warming and drying. The second scenario goes sort of in the opposite direction. More warming and drying means more fire, which means more opportunity for aspen to resprout and maybe gain back some territory. You may or may not know that the 20th century is one of the wettest centuries in the last 2,000 years, depending on where you're located in the West. So we're coming out of a very wet century. So we need to be a little careful about when we hear all these dire predictions of climate change. When we transition from a wet century to a drier period, we should expect a lot of this stuff. We should expect a lot of fire. Look at the window of time that they're looking at. Most climate modeling windows are 30 years. So when we start talking about 100 years or 1,000 years, the picture looks really different. And these, it's not a right or wrong thing so much as there'll be some benefits to aspen, some opportunities, and probably some shrinking of habitat. The wild card here is what I mentioned early, true aspen seedlings, which can fly for tens of miles because they're so tiny and they're like cottonwoods, they're on a little puffy cotton parachute. And how those will spread into new habitats and potentially colonize new areas is a huge unknown. So I just want to point out that if you're a disturbance dependent species, there could be some, you might say, some openings or opportunities with more fire and more drought. The key to all this is managing for resilience. And what really concerns me with the dire predictions of climate change in terms of applying the science to the ground is that people will throw their hands up and say, this is too big, we can't do anything about it. Well, it turns out we can. If the analogy of the climate change shift is a cliff and we're rushing towards it, we can deflect our route, we can slow it down, we can improve the habitat, we can treat our landscapes better so that they are more resilient to the changes coming, while we're simultaneously working on that bigger problem of slowing down climate change. But if we go the opposite way, if we make our systems more vulnerable, the impacts are going to be more acute and less reversible. So herbivory, in my opinion, is the biggest issue threatening aspen systems in the West. Some of these herbivores are domestic livestock and some are so-called wild animals. I say so-called because their numbers are regulated and to some extent their movements are regulated by agencies, mostly state agencies, a little bit of federal agencies. And all of these critters want to get their mouths on these super nutritious young aspen suckers. If that happens over a long period of time, we have systems that are really, really spiraling. And it's happening to greater and lesser extent all across the West. Some areas are much worse. Some areas are having not much of an issue at all with this herbivory. So what does that look like? This is the ridge now of somebody who wants to, that I was trying to think of at the top of the Gros Ventre, way up there. I can't think of the name, where aspen monitoring has its longest history in the West, particularly in relation to fire. And I've drawn a blank on that. I'm sure there's people on this call who know the name of this place. It's way up at the top of the Gros Ventre drainage. Anyways, we went up there about 10 years ago. The guy sitting in the middle is Dale Bardos. He was there in the 70s monitoring. He's supervising us more now. Remeasuring these plots where aspen has sort of disappeared from the landscape in a lot of patches. You could see that it grew there. It probably burned or it just died off, but where's the next generation? Remember, this is what aspen specializes in. It does really well. It provides shoots after it's hurt or damaged or pinched or maybe even called names. And so this herbivory, this is chronic herbivory, where that tree is about 5 inches in diameter, is probably at least 20 or 30 years old, but it's not even a half a meter high. And this is happening not only across Wyoming, but across other areas. And bear in mind, it's not all doom and gloom. There are areas that are doing pretty well as well. This is where the culprit left some evidence. This is Elk Pellets. And this is where two herbivores are sort of competing. One herbivore has a very positive impact on the system. One in overabundance does not. So this is, I actually don't know what is browsing on the young suckers, but you can tell what was eating those saplings and larger trees. So that's beaver harvesting that and making a dam just downhill from here. And I'll come back to beaver in a minute. So these browsing animals are fine in some balanced quotient. But we as the public, we as scientists, we as managers have to realize that we've gone way, way out of balance in some areas. This is an interesting slide. It's from a private sort of, I guess you'd say kind of ranchette village where the Uinta Mountains meet the Wasatch Range near Camas, Utah. And this is a pile of aspen residue from some cutting. And those are all elk tracks going around it on top of it. I'm telling you, this wood, and particularly the green chlorophyll part, even the wood chips, every part of the tree is highly nutritious and the animals really love it. And they're basically saying, thanks for putting this winter food out for us, when that was not the intention at all. So this is one of my only or second data slide, and then I'll lay off of you for a while. This is a complicated graph. It's a type of ordination. We come up with two axes. One represents the success of the recruitment. And recruitment is when we get the aspen suckers to be taller than head height or taller than the reach of the browsers. And the other one is just the number of total live and mature stems. The main axis there is on going left to right. And you'll see, I think you can see my cursor here. The abundance of elk is in complete opposition to successful recruitment. And this is a common pattern that we see across the West. Here we rated stands good, moderate, and poor. Well, moderate's all over the map. The good ones are all over here on the right. The poor ones are mostly to the left of the center of this graph. And so we have trouble with recruitment if there's too many browsers. And it could be any of those four culprits or a combination of them. And the reason the way we measure how they're there is by counting poop, basically. And it's not a perfect way to account for visitation, but we match it up with how much of the stems are browsed and how much the animals have been there. So back on track. Herbivory matters. Southwest Wyoming here. This is what we call a see-through stand. This is a very unhealthy stand that has very little future. If you go to an aspen forest and you can see through it, you know that you're missing the babies, the teenagers, the young adults, and the mature adults, and all you have are the senior citizens left. If that was a human village, it would not stay around long. It's simple demography. And all the young ones, if they're eaten for long enough, you get these big gaps in the forests. And the old ones, remember, they don't live that long. Let's just say roughly 100 years. And so they will start falling over, and they're waiting for the other ones to replace them, and they're not there. And you see that down in the foreground too. You have a lot of trees have gone down, and we're completely losing this aspen forest. And this is the stable type, right? So it's not going to burn very well, and there's not going to be conifers growing in. So ungulates, what are the populations? What are the numbers? And what's the movement? Doesn't matter if it's cattle, elk, deer, sheep, maybe even moose. One place I was at, it was wild horses. What are the numbers and what are the movements? Are they moving a lot? Are the numbers low, moderate, or high? And just graphically, high numbers is what we have across much of the West, certainly in Wyoming. I work quite a bit with Wyoming Game and Fish. And we have low amounts of movement relative to past times when there was active predation and other things happening. So let me superimpose our Aspen graphic and remember our obligate species. Our species diversity follows that path. If we're in this pattern, which we are in many places, but not all. What we need to do is try to bring those closer together in a relative sense. Bring the numbers down of the animals. Remember, they're meant to be kept at moderate to high levels so that we can, to be crass here, so we can sell hunting tags. And we don't like predators that much. We've been semi-successful in the Yellowstone area, reintroducing wolves and bears and things. And so there's some good things going on there, and we'll see that in a minute. But keep the numbers high, sell the tags, that brings us income, which helps us manage the system. So there's a little bit of circularity in the logic there, but adjusting those numbers keeps us going in a lot better fashion. And of course, the punchline of this presentation, where all those obligate species go. So this is the Lamar Valley. You see that gap, you see the see-through, but you see some exciting stuff happening underneath. And before you get too excited, we have to really moderate our trophic cascades fairy tale because it's not exactly a finished story, let's say that. Okay, so we had a lot of years with nothing coming in there. And then the last 10, 15, 20 years, we have some new aspen growth, just like that, magic. I can guess that most of it is not true seedlings, but it's sucker reproduction. And so that's a good trend. But we're pretty confident in this trophic cascade story about the numbers part. The numbers have gone down for various reasons, some of them related to wolf presence. The movement is still a highly debated story. So hold your fairy tale a little bit when you tell that story around town or over a beer or something. But still, that's a really good sign. We love to see that. So one more time, switch channel. So let's just take that visual tour I was talking about and look at some of the diversity of life forms, because it's fun to do. Fungi growing on the trees, associated with the roots. Remember, that's going to cause internal rot, in addition to, I think, looking pretty, which will send the tree on a certain path, which will open it up for the potential of cavity nesters. And then you have primary, secondary, and tertiary cavity nesters. Scarring on trees opens up more habitat for lichens. I know you're all looking after the lichens out there. And so let's zoom in on that. Let's go into Paul's world for a minute here. This is Physia biziana on Aspen. Xanthoria, and you'll see that's a conch. That's a fungi that grows in the tree. It tends to, internal to the tree, there's probably a meter of rot up and down from that. When you see those little conchs hanging off the tree, sometimes pretty big conchs. There's another Physia species here, Physia ascendens. One of my favorites, this is Phaeophysia nigricans, or it's a shadow lichen. Most lichens don't have a common name. This one happens to, thanks to my friend Roger Rosentretter, who's a champion of common names of lichens. A different species of Xantho mendoza there. I think that's Xantho mendoza galericulata. What else do we have here? Okay, we don't often get fruticose lichens, the bushy ones, the three-dimensional ones on Aspen, but whenever I see them, I get all jazzed and excited and grab my camera. So, and this is from Wyoming. So this is a big old aspen. There's a high correlation of where the lichens are in aspen to where the bark is roughened. It doesn't, lichens don't grow on the smoother bark for the most part. This is Usnea hirta. So moving on down the line or up the line, depending on your preferences, we have a lot of pretty stuff supported in these systems. Of course, I just picked a bit more colorful flowers, maybe a little biased toward this audience. Fragaria, or the strawberry. This collision between aspen, or intersection between aspen and beavers, is unbelievable for biodiversity. Two keystone species working in conjunction with each other. If you look at the surrounding landscape and you see all these trees cut down by beaver, you might think it's a disaster, but it's just poetry in motion. You're moving water around the landscape. You're having different age aspen. You're having all the species that specialize in those different age classes. You're improving the fish habitat, the wildlife habitat. It's just crazy biodiversity when you hook up aspen with beaver. And this is from Spawn Creek in northern Utah. Other signs, so we're just looking at signs of wildlife. Bear claws climbing the tree. Little kitty cat scratching post in the Book Cliffs area, eastern Utah. This is one of my favorites. This is the black canker. Looks like a huge split open in the tree. This is a fairly common canker in aspen. Looks like a nice home. Wildlife, this is from some private land near Arco, Idaho. I'm sorry, I'm not a birder, so I'm sure if someone could drop that in the chat, if they can ID the species, that would be appreciated. Also near Arco. This is from the Ricketts Ranch area near Hoback Junction. So dead trees have a lot of value. This is from James Schuler at the Wolf Creek Ranch, where I was showing that other study where we had the elk grazing on the pile of aspen. And finally, this one comes with a little story. This is from a very remote area, the House Range along the Utah-Nevada border, but I almost stepped on this little fawn because it was hidden outside the forest. Now there's a theory, and I emphasize a theory, that overabundance of elk are pushing mule deer out into open and vulnerable areas. And this animal, I could have picked it up and put it in my truck. I'm standing right over it and didn't intend to get that close to it, but I took a photo when I was there. But in a vulnerable place in the first few days of life, hanging out outside the forest where normally there would be cover in a forest. Mule deer populations, generally speaking in the West, are of concern, whereas in many states, we have a lot, if not way too many elk, particularly in Colorado and Utah. I don't know if Wyoming is quite as much, but there's an estimated 286,000 elk in Colorado. They used to have elk farming there. If that might be part of the issue.
Paul, just so you know, your slides are being delayed somewhat significantly, just so you know.
Oh, my bad. I'm sorry. I did not know that. Thank you. And I'm coming into the end here. I will try to go slower after the click. So we have these encounters, sort of conflicts in aspen habitat. This is a bear that broke into a yurt, south central Idaho. Probably drawn by the habitat of the aspen, but sometimes we have to rethink on how we interact with animals. This, some of you may recognize from Gardner, Montana, right across the street from the big old historic gate into the park, Yellowstone Park. But look at that tree on the left. They put a fence around it. It's getting mauled. It will unlikely to live. And you gotta love the irony of the elk ink in the back. So bringing it back around to people, because this is people habitat as well. These are some collaborators of mine doing monitoring in Lamar Valley in Yellowstone National Park. By the way, this was the day of the eclipse. And we were at, I think a lot of you were all, if you're in Jackson area, in the 100% range, but we were in the 98%. So it didn't get dark, but it was sure a special day. It was so cool to be way in the backcountry of Yellowstone. And doing this monitoring with some studies that are just coming out, and this is going to add to that story I was talking about, elk movements and wolves and aspen health. And so people have a lot to do here, building resilience, monitoring, understanding this system. People enjoy these areas for recreation and homes. They're beautiful, they're aesthetically pleasing. But look at this forest. Where's the young ones? Where's the middle-aged ones? This happens to be the Pando Forest. There's actually a couple of homes on the edge of that world-famous forest in south central Utah. And we're talking about future generations too. What are we going to leave them with climate change coming on, with resilient systems, with the ability to go out and see all these beautiful species that are shown in just a few photographs of them? It's a human thing too. Just very quickly, aspens around the world. This is a paper I worked on a couple of years ago. 6 or 7 species of aspen stretching all around the northern hemisphere with a lot of the same issues. This is something I'm calling mega conservation. Traditional conservation focuses on one species, particularly charismatic megafauna, and throws millions of dollars at it for small habitat. This is sort of the opposite of that. What if you have sort of common species that are often threatened or diminished that support hundreds of species? If you were strategically placing your dollars, how would you support more species to live longer, to support that biodiversity? And it's really not an either or question. It's just something to think about, how we go about conservation at the global scale. Just a little visual on some of those places. From Russia, where they're still plowing out aspen so they can grow more timber, to China on the right, to Scandinavia, where they have basically only aspen in plantations almost, and preserved because they've cut out about 98% of their aspen, to the parklands of Canada, where it's pure aspen, but it's a lot of it been converted to farmland over the last 150 years, to our Rocky Mountain region. All these issues, there's a lot of overlap. So finally, I'll try to slow down here. Just a little bit about the Western Aspen Alliance. A nonprofit based at a university is kind of unique, but it's basically to get information out to people so we can make better decisions. The makeup of the Western Aspen Alliance, a free membership. There's optional donations, sort of like public TV. But our biggest membership is the U.S. Forest Service, and secondarily is kind of all education and universities. And then, you know, BLM, other NGOs, a lot of people, private citizens, and so on. We put on these workshops, we make materials available, we do webinars, all kinds of different things. A quarterly newsletter, and we don't pester you. You get 4 emails a year with the newsletter. If you're interested in that, I urge you to go to that, either, the website or Facebook page, figure out who we are, and happy to interact with you too if you want to just email me. So with that in mind, just want to remind you that I have some folks that help sponsor us on an institutional level, and thank you so much for your time. And I will turn off the stop share, or turn on the stop share. And I think we're okay. We have a little time for questions.
And just so you know, we did get an answer to your ridge by 2 people that I'm pretty positive know where they are. Breakneck Ridge, does that ring a bell?
That's
Thought
it.
so.
Thank you. It's good to have a live audience.
And then I think the other answer to one of your questions was perhaps Buick's wren.
Okay.
For your little wren picture that you had there. Yeah,
that looks like a wren to me, but I have to say that that one's, it's not in my wheelhouse, avian ecology or avian ID. So I said a lot of stuff. I threw it out there pretty fast. Any reactions or questions, thoughts?
Paul Allen, would you unmute yourself and ask your question?
Well, I had several questions, but the last one, I stated that there's no denying that the Aspen Forest supports a vibrant diversity of creatures, but most communities do. And when you're promoting one community over another, you're usurping space that another might utilize to ecological benefit. Can you comment on that?
Yeah, I may get this a little wrong, Paul, but I'll give it a run. In areas where aspen is already present, and through our various human intrusions, sometimes we favored other species that are there, either overtly or covertly. And so we're not advocating to push other species out so much as allow a species to thrive that was naturally there. And then, of course, as I keep saying, all the cascading species that are dependent upon that.
Well, I'll follow up with that then. You mentioned species that were dependent upon aspen forests. And at one point you had a slide that showed, I think, obligate dependence. Can you name a few obligate dependents of aspen forests?
Well, those couple of lichens I mentioned, the Phaeophysia, nigricans, a lot of those wildlife species that Don DeLong has listed are using aspen on a daily basis. And so those are the species that I'm thinking of.
Thank you so much.
Mm-hmm.
We have a question also from Dave Jordan, which I think will also add in some to keep going with something about the fire. And then I'm going to call on Melody in a moment. But Dave, can you unmute and ask your question?
Yeah, I actually am the one that asked the question.
I read.
We have a grove of aspen above us on Saddle Butte, and there was a fire that came through here a couple of summers ago, 3 summers ago. The wood is still standing, and I keep meaning to go up and check out whether or not the root system survived. Is that how they can survive fire? This was not a big raging fire. It was a creep along the ground kind of fire that took out that grove.
Yeah, let me start sort of at the back end and come forward. It's sort of a myth that fire gets so hot that it kills the aspen roots, but certainly not a creeping fire. Even a very hot fire, aspen roots are well insulated. That doesn't mean they won't get scorched in some areas, but if you think of this immense web of roots under the ground, occasionally there'll be a hot log that'll burn very hot and may sever one tiny section of that. Remember, the log is linear, and this network of aspen roots is not linear, it's aerial. It's across the whole area. So the amount of roots that would get killed or singed from a fire is negligible. And you'll see that, you should see that in the response. And so there should be some strong growth there, even with a light fire, because probably I didn't understand quite if the standing aspen trees were dead or alive. And hopefully it's a mix of them. You should get a strong response.
Yeah, it's not clear whether they're dead or alive. They look dead, and they didn't produce leaves the last 2 or 3 years.
Okay. So this may be an instance, and it's hard for me to imagine not being there and seeing that, where you had a stand replacing fire, in quotes, that was very low, creeping across the ground because of that thin skin. It killed the overstory of aspen, but that's just like a gift to an aspen forest. It should respond very strong and grow back.
Yeah.
Of course, we keep coming back to this, what's the browse level? It may have just been a giant salad bowl, and all of the ungulates in the area came there because it was easy access and they ate everything. So now you've got it killing the old ones and eating the young ones, and you can only hold out for a few years if that pattern keeps up.
And that could be possible up on that ridge. We get a lot of mule deer that winter up there, as
Right.
a thought, Reed and
Right,
Dave.
right.
Yep. Melody, you've had your hand raised. Can you unmute and ask your question, please?
Yes, regarding the catkins, does all aspens have catkins, or sometimes it looks like maybe one grove just 1 year has no catkins? Is that normal, or what's the catkins all about?
Yeah, occasionally, I did not explain that clones are either male or female, the entire clone. And so their catkins are going to be a little bit different, but they should all have catkins. They'll occasionally take a year off, but they should flower. The catkins is just the flowering parts.
an
Does
all
that answer
male
your
and
question?
all male and female all have the same type of catkins, or there will be differences?
There are differences. One is a little bit longer. I believe the female catkins, if I can't recall exactly, one is a little bit larger than the other. And if you look at them under a hand lens, they're going to have different flowering parts, of course, because they're male and female. But they won't necessarily flower every year, but most years they do. My point is, say in the Pando Aspen Grove, it's 106 acres. All of those estimated 47,000, what we would call trees, which are actually really kind of branches, they are all male. The entire thing is male. Does that make sense? So it's dioecious.
Right. So yeah, indeed, it's rather interesting for me. Yeah.
It's
Thank you.
interesting to me too. Yeah, we should go on a hike sometime, Melody.
Okay, thanks.
Get it out in the
Yeah.
field trip. Paul, I have a quick question, and then I'm going to ask Elizabeth to speak up. Is it stolons or rhizomes? I mean, is it actually the root, or is it the underground sort of branching, the way you would sometimes get on an iris or whatever, where it's really a branch underground sprouting up?
Yeah, it's really, you could think of it as a branch. It's really the root system. They're not technically runners or stolons. It's the
Okay.
root system. And that one photo you saw, the sucker coming directly off the root.
Okay.
There's these, what they call primordial buds, but there could be hundreds of them in a 10-centimeter length. And if they're stimulated right, it just takes off. And it's a hormonal relationship between when the tree dies or is even injured. It sends the hormones to the roots, which say, okay, it's time to punch up a lot more suckers because I've got to take care of my future.
Great. Thank you. Elizabeth Barnes, do you want to ask your question?
Over 30?
Hi, thank you, Paul. This has been a wonderful presentation. My question stems from, I'm working on a project to reforest after a very large fire. And there's some areas we can't reach, and we think, wow, it would be great to just broadcast aspen seed because they lend so much fire resilience to the landscape. But I'm wondering, how specific are aspen to the surrounding habitat? Are they really loyal to certain soils or moisture, or are they more generalists?
Great question. Well, having that huge ecological amplitude across the whole continent, you could say in a sense they're generalists. However, in the Western US, they're mostly on mollisoils. Traditionally, if someone wanted to, putting up my quote fingers again, replant aspen, they would do so with little pieces of root rather than seeds. The seeds are super finicky. They have have to be on exposed soil, ideally that's burned with a bunch of carbon in it. They have to get moisture at the right time, and they're only viable for about 14 days. So when all those things line up just right, you get some seedlings to grow. And it's to put it mildly, it's a big experiment. So you might put a lot of effort in and fail. If you grow them from rootstock, you would typically start them in a greenhouse, make sure that the primordial buds are sprouting, you get them going, and then go out and put them on the landscape. And even then, you're probably going to have some failure if they're not used to that specific environment. So it's a lot of trial and error, I'm sorry to say. And then the first order of any kind of revegetation is, did this species grow in that area at all prior to this? And is it even logical that it would grow? Is it too high or too low? And all those questions, dry, wet, altitude, things like that. So some things to consider.
Thank you, Elizabeth. Laura Jones has her hand up, and then I'm going to scroll down for some more questions too in the chat. Laura, you go ahead.
Yep, thank you. This is Lena here for a question.
So you showed how there were like some aspen forests that were unhealthy because they're so small you could see right through them. How long would it take, if it were to happen, for them to be big and healthy and like big and diverse again?
Okay, yeah. So I called those see-through forests, and actually it was only the old ones that were left. And that's why there was all the young ones were missing. But really these trees grow pretty fast. If they weren't being overbrowsed, they would start to grow back immediately. And in 5 to 10 years, they would be much taller than us. So that's pretty fast for a tree to grow. And so that would keep coming back as long as we could sort of figure out why all the young ones were getting eaten and take some approach to stopping at least so much eating. You know, browsing isn't good or bad. It's only bad if there's too much of it. We're looking for that balance of the animals not eating too much. We want all those animals on our landscapes, on our wild landscapes. We just need to keep the balance. So, you know, within 5 years, it could be taller than our heads, pretty quick. Maybe it seems like a long time to a young kid, but 5 years is pretty fast growth for an aspen tree to get that tall.
Quickly.
Terrific.
Thank you.
And Canker, I have you down as a question here about the Palouse.
Yes, thanks. Thanks for that wonderful talk. This is really, I've learned so much. I was interested in the, up on the Palouse, there are aspen stands that cycle with hawthorn stands. Like
Ooh.
they'll grow up and then they'll die out and hawthorn will come in and then the hawthorn will die out and the aspen will come back. Are you aware of other places in the West where aspen cycles with a deciduous tree like that?
Great question. There's a little bit of that in my area with big tooth maple in the draws. And I have to say, I'm going to admit my ignorance here, Lynn. I don't know about that situation. That sounds interesting with hawthorn. I know around Wyoming, there's interchanges with serviceberry. For example, at Fossil Butte National Monument, there's surprisingly a lot more aspen at Fossil Butte than you imagine in your mind when you drive by there and you think it's all sagebrush. So there are other instances of that in the Southwest. There's a little bit with Gamble Oak. But it's interesting that our past in terms of research and certainly in terms of the field of forestry, we didn't explore things that didn't have more human benefit. So we tended to neglect in the West those broadleaf tree species and their ecological relationships. So those are great questions that I don't have really great answers for, Lynn.
Thank you.
Mhm.
Interesting to hear.
Mhm.
Anybody else with a question? I think we're rolling down here. It's almost 7:15. I want to make sure Paul can go have his dinner, but we are here to answer your questions. So if somebody wants to unmute and say something, I don't think we'll have too much overlap at this point. I see all is quiet.
Well, if we're going to sign off soon, I want to encourage people that I would love to come out if we can arrange a time to do a hike with the group. And also I would encourage you to check out some of these free resources and look at our website.
And I want to thank you, Paul. And yes, we'd love to get you out here. I can assure you that would be fabulous. And it'd be also great to just for people to start looking at the wonderful plants and diversity underneath the aspens. And then more on the ecology. There's a lot for me about, you know, the aspen bark and the green and the white and all of that, which is intriguing to me. And just the clones that all look so similar in their details sometimes and the way they form. So aspens are an intriguing plant. And then, as you said, the ecology and the connections are just huge. And maybe we'll get you come do a lichen program as well. So
I'd be excited about that. And I have to say, part of my hidden motive is that I can learn a lot from you folks too.
well, I think we have a pretty good gang out here who would keep
I'm thinking you do. Those questions were excellent.
Yeah. So with that, everybody, I will say good night, and I'm going to end the recording here.